Hello, it's Anthony from Campbell Associates. We supply solutions for noise, vibration and air. Today we will look at the Norsonic 145 and Nor150. Congratulations on purchasing your new instrument. The 145 is the product that I'll look at today, but the 150 is in the same structure. The 145 has a battery life of up to 8 hours. You should remember to recharge the battery once it's been depleted, not leaving it with anything less than 20% battery for long periods of time, as this will not prolong the battery life. You will need a calibrator to calibrate the microphone, so hopefully you have one of those in your kit. This is the sound level meter. It's a full color touchscreen display. You have an LED on top of the meter, which can actually be seen on the right hand side of the virtual meter today. This LED will change color based on the application and what you're doing. So if you're recording, this will go green. It may flash blue, it may go red if you're clipping, or amber if there's some kind of error or something like this. So if you have a look through the manual, this is explained. The keypad is illuminated. There are some controls on the bottom. So you have a LAN input, a power socket, an SD card, supports micro SD. Up to 128 gigabytes. On the 150 it is a little bit less. I think it is 64. And there are a number of buttons on the keypad that I will discuss today. The Norsonic 145 can have this application screen, so it looks like your mobile phone, so we call these apps. When you turn on the meter, this may not appear immediately. So if this doesn't, I'll show you shortly how to get this application screen up. If you do see it, then you'll need to make sure that you have this button at the bottom that says hide. If it says show like this, then you need to tap until it says hide. You'll then be greeted by 3 of your apps if these are installed. The calibration intervals for the equipment. The sound level meter should be calibrated every 2 years. Let us know we can actually remind you of this. And the calibrator is every 1 year. You must calibrate the instrument with the calibrator at the start of the measurement and at the end of the measurement to ensure certainty of the measurement. So take your calibrator, place this on the end of the microphone. It only goes on 1 centimeter. The calibrator should be set to 114 dB at 1000 Hertz or 1 kilohertz. Turn on the calibrator and then press the cal button on the meter to bring up the calibration screen. So if you've just turned on the meter today, you may need to load in an application first. In that case, tap on the app and tap in the application. Then press the cal button and go through the calibration procedure. So I'm just going to place the calibrator on the end of my microphone. Now you cannot see what I'm doing. I've now placed this on the end of the microphone, and you will see the level increase. I did have a little warning there, so the meter will remind you when it's due for calibration in the 2 years' time. So the next step is to tap on the auto in the middle, and then once you've done that, you need to press the calibrate button, which is at the bottom. You'll start to see the line move through. It's now saying in progress, and you should also be making sure that the calibrate at is at 1 kilohertz and the calibration level is at 114. Once it's completed, it will illuminate orange again. You just need to press the tick key to save this. And what's great about these meters is it does keep a level versus time history of all the calibrations to ensure that we have good repeatability in the meter. So I've pressed the tick to save this, and then we'll be able to move on to the measurement screen that looks like this. In the top left, you can see the battery level. You can press the info key to actually see the percentage. Press the info key again and it will bring you back to this screen. You'll be able to start the measurement by actually tapping on the screen, pressing the start button. I recommend this over the actual physical touch button, and then you'll have the option to create notes, text notes, comments, and if installed, you may have audio recordings. This is not on all meters, but it can be a useful feature. Here we can actually see the frequency display on top and the result screen on the bottom. There are 3 buttons on the keypad that we will look at to start. We have the cal button, the memory key, and the setup key. The memory key allows us to to manage the memory files, and the setup allows us to change the settings. So tap on the setup button and you will be taken to the setup screen. You can then go into applications at the bottom, and here you can see the apps that we have installed on the sound level meter. If you cannot see the app that you're looking for, this may be hidden in one of the modes, because once you've loaded in the mode, say for example building acoustics, you'll only then be able to see all the building acoustics apps. If you're in a different mode, you won't be able to see them, therefore you'll have to tap into, say, building acoustics, and then you'll see a list of all the apps available that are not apparent on the front screen. If you still can't see them, then it could be simply that this button at the top here, this show setup shortcut, has been turned off. Therefore turn it back on so that the app is displayed on the screen again. Okay, so we'll look at a STIPA measurement. This is the equipment we will need. We can go to the next slide. So what is STIPA? STIPA is for the Speech Transmission Index. It's a tool that we use to rate the speech intelligibility of a room. There are various methods. We can use this to compare the quality of the room in various positions. The other method that's been superseded was RASTI. This is superseded by STIPA. And STIPA is a useful tool or process because it helps us handle the reverberation in the room and any distortions which are found with public address systems. So the measurement duration for a STIPA test is 10 to 25 seconds. Today we'll create an app to automate this. So all we need to do is press start, the measurement will run for the amount of time that we need, and then you'll see the results. So it's very quick and easy with a 145. You could also use a Norsonic 140 sound level meter or a Norsonic 150. Both would get the same results. You just need to make sure that you have the matching sound files. So some careful considerations are that we need to be mindful that the value will be lower if the speech is below 50 dB or above 80 dB. There is a target level that I'll talk about shortly. The calibration of the equipment is very important, so we need to do this before and after the measurement. And we need to make sure that we have the right device for playing the sound back on. So if we're using like a PC with a cable to a speaker, and then we need to ensure that the level is correct and that none of the equalization or virtualization or extra bass is on so that it influences the sound. We need to make sure that the sound is as flat as possible according to the standard. So this is the equipment required. We need a speaker. It's recommended that we use a speaker no larger than 100 millimeters in diameter. This is for the speaker cone. We need a STIPA file. We will provide this as a 70-minute audio file, or there is a shorter version, which I believe is a 10-minute file. This is more than enough for carrying out the test. We need a sound level meter. We use a class 1 sound level meter and a class 1 calibrator. The systems we use are from Norsonic. These come with a 3-year warranty and are very robust and reliable for technical measurements. So here's the speaker that we will use. This one, as I said, is less than 100 millimeters. It's actually 63 millimeters on the cone. The standard here recommends a spectral level for the octaves, plus or minus 1 dB. So the table below can help you specify the right speaker, and you could use an equalization to actually help you meet this target, so that we know that the speaker is not increasing the bass or the high frequencies or the mid-range, so that we have the most accurate and certain test for STIPA. Okay, so the process is we will excite the sound through the speaker continuously at a level of 60 dB, which we will first calibrate by using a sound level meter 1 meter away from the speaker, set the volume until we reach the target of 60 decibels, which is A-weighted, and then we need to put the meter into the position of the listener. So if we're looking at a school, we need to set the speaker at the talker, the listener, it's obviously the students. This is the listening point for the sound level meter, and then we can look at the results. Here we can see an example with the rating. So here's an example of the classroom. The teacher is next to the whiteboard. We would have the speaker right here at the level of where the teacher is. We would direct the speaker in the direction of where the sound level meter is, if this is the direction of where the teacher's normally talking. And yeah, we have the meter at the student's location. There's no cables because the meter's battery operated. The speaker may be connected to the computer. I'd recommend probably not using Bluetooth in case you have interference or not very good quality. Yeah, and the measurement will run between 15 to 25 seconds. So here's a review. You should take a number of measurements. In this case, we will take 6, and we will take the 3 measurements from there, and if there's a variation of 0.03, then we'll take 3 more. It is a requirement that if the simulation is for a raised voice, then we should increase the sound level of the speaker by to 70 dB. We should also look at negative effects on the instrument. Of course, if we're getting any reflections, we're within a meter of the wall, then we may need to apply a correction of up to 3 dB. And we also need to make sure that the person that's carrying out the measurement is also not influencing the measurement negatively. So perhaps you're getting some kind of reflection or absorption off your body because the sound level meter is too close to you as you're doing the measurement. So let's start it up. All we need to do is turn on the speaker. We need to play the STIPA sound file. We should make sure that we're using a WAV file, not an MP3, because it's compressed and it will affect the actual clarity of the recording. And we should avoid Bluetooth. If we can use a cable, this is definitely much better. And we need to set the volume appropriately to 60 dB. So to start the measurement, it's very simple. We're in the STIPA mode already. We simply fire up the speaker, as I said. We now press the start. The measurement will run for the period of time that we've set this to. This can be adjusted in the settings menu. I'll show you this shortly. And the measurement is continuing. Now I have a calibrator on the meter by mistake there. But let's see what our result will be. At the moment, it's not looking too good. So it's a good, but very questionable. So this is showing some uncertainty here, and we need to correct this. You can see the correction is here with the answer, STI. We get our rating. We can actually view this data in the results as a table. So if we tap our finger on this screen here, and then tap on the table, we can then see the individual frequency bands. We can press the table again and it will bring us back. And we can also look at the corrections being applied to the sound level meter. So to bring up this menu, just press and hold your finger on the screen. You can see the auditory correction here. We can enable the background correction. Then you will see the background noise correction here. We can amend the background noise correction, shall I say, by pressing the tick on the keypad, going to define background spectrum, and then we can enter in individual values. Now, this is a little bit more long-winded to do it this way. Perhaps what we might do instead is just to actually carry out a background measurement using the environmental mode, save that as a file, and then we can just load this into this spectrum here. So we can find the environmental measurement, which is normally indicated through a green app. So if we just find one of these measurements, I'll take the one at the bottom. It will then say, do you want to open this? We can say yes. And then it pulls through the correction that we will apply. You can obviously adjust this. If we press the tick on the bottom, this will now apply the background corrections. So here's the scale for the result, 0 being a very poor measurement and 1 being an excellent measurement for speech transmission index for the intelligibility. So you get the number here. You also get the CIS value, which is not one that we would use, and this is for emergency purposes for sound systems. We could also look at the listening difficulty in the standard, and then we can judge how good we think this measurement is, how good the room's performing, whether there's any difficulty with the recognition of the words, or if it's hard to listen to, the pronunciations, and so on. And there's also a grading matrix in there as well that you could also look at. Once we're done with STIPA, we can look into the reverberation mode. This is done in a different place. So if we go to, let's clear this measurement. I can clear the measurement by pressing the X key. Then if I go to Setup, go to Applications, and go to Build and Acoustics, we will then have the option for the reverberation. We're going to be using the impulse method because we would be using a balloon in this case. If you're using a noise generator, such as a speaker, then we would use reverberation noise. So I use reverberation impulse. If I press the tick, this will now load in the settings. These can be adjusted by going into Setup, go to Reverberation, and then you can make adjustments. So for example, the trigger level, you may need this higher if you're triggering the start of the measurement all the time. Okay, so maybe 70 is too low. In this case, I'll leave it the same. I have a trigger frequency at 1 kHz. You can extend the max expected RT, which is RT is for reverberation. So if you're measuring in say a very large room in sports hall, the RT may be longer. We can also adjust other settings in here, such as the level, which will affect the things like the level durations, or how long we're doing the measurement for. So this can also be adjusted in the STIPA. You have these options too. Once you're happy with all the settings, which can be in any mode, then you can save an application for later, which speeds up the time for your setting your meter up. So if we go to memory, in here we can go and save the setup file. We're going to manage setup files, save measurement setup as, and then we can tap on this button to create the app, show a setup shortcut. This actually creates the app icon. You can leave this off. It will just be within the actual main mode app. And then you can give this a name. So today I'll just call this test. And then we'll press the tick, and this is now created. Once this is created, you'll be able to find it by going into the setup and then applications, which I can show you here in applications. So the test will be just down here. Okay, so to start a reverberation measurement, simply press start. Now, if you've already started a measurement by mistake, you may need to create a new one. So just go into setup and then click new. This will allow you to start a new project so that you can then start the measurement. I've started the measurement. I will now clap my hands. This will probably create an error. But what you will see here is the frequency display on top and the level versus time on the bottom with the T20 marked. We're waiting for the decay of the sound, then we measure the difference, and this will give us our result. We should be looking in the A column, the A weighted level, to see the overall value, but you can also look via each frequency band. Once you've saved this measurement, which is done by pressing the tick key and then entering the name of the file, the measurement will reset back to the measurement screen as seen here on the right. To get back to this view here that you can see in the presentation, then you will need to press the project key, which is on the bottom left of the instrument. Then you will need to go down to reverberation. You may not have all the other options that I can see. This is just part of my meter. Then press the view key, which is on the left-hand side, and this will allow you to see the measurement data again. Okay, so that measurement's done. I would like to clear that measurement. I'll press the X key just to clear this out. I would now like to look at downloading this measurement. So you will need some software from norsonic.com/downloads. This is called NorConnect. We use this to transfer the measurement file from the instrument to the computer. You can download via the SD card, the USB, LAN or Wi-Fi. If you connect to the USB, you'll see the instrument appear on the right hand side. You will need to make sure that you're set in the right mode. So there's a mode icon here. This is set to build and acoustics. Change this to STIPA if you're looking for your STIPA files, or environmental for your general measurements. You then take the measurement, you drag it from the right hand side, and you drag it into the left hand side, and this is now downloaded to your computer. You can create folders, and you can view this measurement, and you'll be able to open this in Excel. There's an Excel button at the top. You select the measurement first, then click Excel, and then you'll be able to download or open the Excel sheet. You'll also be able to view the measurement inside the software by simply clicking the graph or double clicking the measurement. If the USB is not working, you will need to initialize the drivers for the instrument. So there will be a button in the right, an information button, which will bring up another menu, which will allow you to initialize the driver. If you cannot find it in this right-hand icon, then you need to go to the left-hand icon under Norsonic, find again the information button or the settings, and find the initialize driver. This will then run the procedure. You need admin rights to install the drivers for the instrument, and then it will work via the USB cable. If you're looking at using the Wi-Fi method, this can be done by making sure that your meter connects to the Wi-Fi in the local network. If you go to Setup, Instruments, Communication, then go to Wi-Fi, then you'll be able to search for the network, type in the password, then you'll be given an IP address. In my case, it's 192.168.0.34. I then would type this into the software. So in the software, you use the connect button, you type in the IP address, you press connect, and then the measurements will appear on the right-hand side. Again, if you can't see the measurements, it may be because you're in build and acoustics, STIPA, or environmental mode, and you'll need to change NorConnect's mode to display the measurements. So here's an example of some measurements. We have our build and acoustics general measurements, which are double-clicked, which brings up the frequency display and the level versus time graph. Thank you for joining me. This is a quick introduction on the Norsonic Nor145 and Nor150 for STIPA, Reverberation, and NorConnect. You were speaking to Anthony at Campbell Associates. If you need any additional support, please email support@campbell-associates.co.uk.